Hello guys and welcome to this our graph on isomorphic, connected and adjacency matrices. Again, why are these titles so long? Yes, my name is Darren from Maths Guru and it's really good to see you. Thank you so much for watching. If you haven't already done so, before I get into this stuff, can you subscribe? No one watches maths videos. Really, no one watches my videos. Maybe I should be getting the hint by now. Start a whole new TikTok career. I'm on TikTok. Moving on. If you can subscribe, it just shows me that someone out there is watching. It means the world to me. Yeah, if you want to turn notifications off, but just subscribe and let me know that you are out there and you have watched this video. And if you can, leave a comment below. Let me know what you thought of the video. Tell your mates and tell your teachers that there is actually a resource out there that's pretty good and doesn't suck. What are we doing today? Well, as you can see here, I always put the learning objectives, and these notes, everything I do behind me, are downloadable from maffsguru.com. Oh, yeah, see, could I be any more helpful? We've already done what a graph is and understanding why a graph is important. We've looked at some language. Have your summary book. Guys, if you haven't got your summary book with you, pause this video now and go and get your summary book. Write stuff up. We've looked at what a vertex is. We've looked at what an edge and multiple edges is. We know what degrees of a vertex are and why they are so important. And now we know about loops. Did you remember the gotcha from the last video? Gotcha, yes. A loop, one edge, 2 degrees. Now, what else are we going to move on to now? Well, we're going to look at what an idea of an isomorphic graph is, what it means to be connected, and I'll come into that later because I'm sitting in a room talking to myself. I have no friends in life. This is all too much. I want to know what a bridge is. Go on. You're in Australia. How many times have you used? Come on, mate, build a bridge. Yeah, and know what an adjacency matrix is. That's probably the most complicated part of this whole video. Now, in our previous videos, we've looked at all the language that you need to know, right? So what do we notice so far? We know that this thing here is called a vertex. That's weird. I, for some reason, thought that you were going to shout out at me and go, vertex! That's weird. Okay, so we've got a vertex here, I've got a vertex here, and we've got a vertex here. These connections there, the lines connecting them, are absolutely edges. We notice here that we have multiple edges, all right? So there's multiple edges, 2 ways to go between A and D, that works. And we've got here our loop. If we know that, then we can start to build on the next thing, the most important stuff, and that is isomorphic graph. Now you're gonna look at that and go, who on earth are the two what is that called? Plasticine? Plasticine, can't remember. But basically, do you know that that is morph? And that's why every time I do isomorphic graphs, I think about morph. If you haven't got it, YouTube him. Literally, these are what I got in entertainment when I was a kid. Please don't feel sorry for me, yes? But basically, on Tony Hart, the same people who did Wallace and Gromit did morph. Mind blown. But anyway, you're sitting there thinking, what's that got to do with the price of fish? Well, it's got morph in the title, isomorphic. I was going back to my childhood. Now that thing there is awesome. I quite like that. And again, it reminds me of another thing I tried to do as a child. Do you remember ever doing this where you would try and draw the house with the cross, but you would do it without taking your pen off the paper? I'm talking to myself again, aren't I? You haven't done this at all. Try it. It's so not fun. If we look at this graph 1 as we see here, and thank you so much to Cambridge for allowing me to use your examples. You guys rock. Thank you. But if we look at this here, we got an idea that A, B, C, and D are obviously 4 vertices with various connections. Now, I don't know about you. I don't like the idea that these things here are crossing. I don't like that at all. Wouldn't it be great if we could draw this diagram in a way where there were no crosses? That might be useful for another video. But we can actually draw that graph in different ways. Now, what do I mean by in different ways? We have to maintain the connections. Let's have a look here. So, as it turns out, we can draw this in different ways. Look at this now. So this was my original graph. I've got one connection from A to D. Now, if you look at graph 2 and graph 3, is there one direct connection between A and D? Well, actually there is. So there is my one connection between A and D there, and there's a one connection between A and D there. Oh, awesome. There's one connection between A and C. Oh, I've got a connection between A and C there, and a connection between A and C there. There's one connection between D and B. One connection between D and B there, and one connection between D and B there. One between B and C, one between B and C. Where are we? Between B and C, and then obviously one between D and C, one between D and C, and one between D and C. So what we've now proven is that graph 1, 2, and 3 on that behind me are actually the same graph or they contain the same information, they're just drawn differently. Now I'm going to get really worried here because I've just read a really interesting website where people jump up and down about this particular exercise and say, oh, isomorphic is not isomorphic and da da da. Look, for the maths purists out there, I'm sorry if that doesn't fit with the worldview of isomorphicism. But for me, teaching further maths and general maths, that's really what it boils down to for this particular exercise. Please don't flame me. All right, so for those of you who are not maths purists out there and just doing this because you've got to, it's a way of drawing the diagram. But what really like about this is you notice that whereas on my first diagram we had that line crossing there, no deal. None of these, graph 2 or graph 3, have the lines which cross. And that actually becomes really important later on. So when we can draw these things in a different way, they are called isomorphic, right? So it morphs. Now, the thing I like now is about connected graphs. And as I say here, we all want to feel connected in life, don't we? I'm again sitting in a room talking to myself. This is so weird. Yes, there are many things I'd like in life. Friends, respect, a pay rise, fame, fortune. No, I don't want any of those things. All right, but connected graphs are also important. If you now look at the screen behind me, and again, your summary book is so important for this stuff, isn't it? Put your summary book, put it in, put this in, copy it down, download it from mathsguru.com. We need to know what the definition of a connected graph is, and I've put it here. A graph is connected when every vertex is connected to every other vertex. Now, this is the important thing, either directly or through another vertex. Now, that is really important. If we look here, we've got graph point A is connected to B, C, and D. That is certainly connected, but it doesn't mean that all points have to connect to all other points, and that's where people make mistakes here. It just means, for example, if you look at this one here, A is definitely not connected to all the other points, but I can get from A to C to D to B, or I can go from A to B directly through C and D. So basically, what I'm trying to tell you is there are no loners in any of this. You're saying, what are you talking about, loners? Funny you should ask that. If we look now, what do we notice? Well, I've highlighted in this graph here, and I've noted in this graph here, there is a B and a D. That is me at a nightclub. No word of a lie. You're too old for a nightclub, I know. But when I go to clubs, I can walk in, you know, I'm ready for a night on the town. I'm in my good clothes, and I walk onto the dance floor and I start to do my funky stuff, and what happens? People move away from me quite considerably, normally away from the club. And I become a bit of a loner. Yes, like those year 7 discos where the boys are on one side and the girls are on the other. Again, maybe that was my disco. Shut up, what am I talking about? Those points here, they're very much loners, all right? And in this situation, we would say that graph 1 and graph 2 are not connected. The reason is because I can't get to B and I can't get to D, all right? So in an exam, they're going to ask you what is a connected graph. They may give you some examples and say which of these are connected. Hopefully you are going to know. Now, in this situation here, if we look at graph number 3, we can turn around and say, well, now actually we've got 2 graphs, very simple. We've got one here between A and D, and we've got one here between C and B. Are these connected? No, actually they're not connected, but can we connect them? Well, yes, and again, to use my favorite, you're right, mate, go to Bunnings, build a bridge. I don't know what the accent was, it wasn't Australian either, but build a bridge, how often have you used that expression? Well, that's what you do here. If I was to now connect D and C together, he says not connecting D and C together in any way, shape or form, but assuming I could actually draw a straight line between 2 points, that there would be a bridge. I've built a bridge between 2 separate networks or 2 separate graphs, or yeah, so when I'm trying to connect one point or one section of or 2 different graphs together and I draw a line between them, it's called a bridge. I've literally built a bridge. So as I say here, there's another way of doing it. I could actually build it between D and B if I want to. There's no right answer in that situation if I was just asked to build a bridge. And it says here, a bridge is an edge which, if removed, would leave a graph disconnected. And in that situation, that might be me and my best friend still in a club alone, but where someone's reached out and they're going, come dance with us. It's not going to end well. The last part of this video is really important, and adjacency matrices are huge in exams, right? if you think about it, how much can we ask you so far? Not a lot. So adjacency matrices. Basically, if you've done the matrices module before, you'll know a matrix is basically just a pictorial diagram to show information. And what I'm going to do here is I'm going to draw a matrix. And I'm going to say A, B, C, D, A, B, C, and D. Now, an adjacency matrix shows how many connections there are between any 2 points in a graph. Oh, okay. So let's have a look at this here. This first line here that I'll draw for the moment basically is in the A column and the A row. So how many connections are there directly from A to A? Now you're going to turn around and say, oh, but you cannot pass through another point. It literally has to be a direct connection that goes from A to A and no, oh, do you see what I did there? It's a loop. Now, do we see a loop at A? No, we don't. So actually in that situation, there are no edges connecting A to A. And if I go around each of these and say, well, what about B to B? There isn't. What about C to C? And again, we have that loop. And if you've gone back to my previous video, you'll realize that a loop counts as one edge, 2 degrees. Because we're dealing with edges in this, then we would now say that between C and C, there's actually one edge connecting them. Is there a loop at D? Don't get tricked. These here look like a loop, but it isn't. There's nothing taking me from D directly to D without going through anywhere else. A little bit like Monopoly. You can't pass go. All right, so there's nothing there. All right, so let's now have a look at the next one. So I'm going to look at the B column and the A row. How many connections are there between B and A? There is just one. So there we go. There's one edge connecting B to A. But hold on a moment. If there's one edge connecting B to A, how many edges are there connecting A to B? Oh yeah, one. So actually, as it turns out now, I can put a 1 there because I'm in the A column and the B row, as opposed to the B column and A row. They're the same. There's an element of symmetry here. Let's look at B to C. How many connections are there from B to C? There is just, so actually, let's do B to C. That was silly because I didn't want to do it. So B to C, that's actually going to be down here. So there's one connection from B to C. How many connections are there from C to B? 1. So actually now let's continue a little bit more sensibly. Let's do C to A. How many connections are there between C and A? There are in fact 1. Yes, again. So from C to A there's one connection. And so from A to C there must be one connection. See what I'm doing here? I'm building it up in terms of symmetry. What about D to A? Oh, finally we get some excitement. Well, from D to A there are actually 2 because that's got a multiple edge. So there's a 2 there, which gives me a 2 there. All right, happy with that so far? What about D to B? Are there any direct connections from D to B? And it's got to be direct, you can't go through somewhere else. So D to B would be 0. So that would give me B to D would give me 0. And the only one we've got now is D to C. Is there anything directly connecting D to C? Nope. So that'd be a 0, and that would be a 0 as well. And there we go, that is an adjacency matrix. Now, believe it or not, if I gave you an adjacency matrix, you should be able to take that and then draw out a graph from it. Now again, when you draw them, there are going to be lots of different versions, but as teachers, we're going to know whether you're right or wrong. But be able to go from a graph to an adjacency matrix and vice versa is really, really important. But again, you're just looking at connections and checking that I'm actually right. There we go. That was our correct answer, and it looks pretty similar, exactly the same, to what we had before. Now again, you might have seen here a little shark down there. That caused huge amounts of conversation with my own general group. All of them like, oh, why is there a shark there? Why is it only half a shark? Anyway, putting that to one side, hopefully you've ignored the shark for this moment in time. I don't even know why I put the shark in there. Obviously I was having a bit of a moment, but an adjacency matrix is important, and the only trick, if you remember, that there is here is that a loop counts as one edge. It might be 2 degrees, but it is only one edge. Now, moving on to the last part of this, we are looking at the leading diagonals. Now, leading diagonals and matrices are really, really important. Why? Because they tell me where my loops are. So in that situation, if you've got a 1 on a leading diagonal, it means there is a loop. Very, very important. But also, there is an element of symmetry here. And if you remember from what I was doing a moment ago, if you notice that one there is A to B, that one there is also A to B, yeah? So A to B, A to B. So they have to be the same values in an adjacency matrix. That one there matches up with that one there. That 2 there matches up with that 2 there. So in many cases when we do these things, it's easy. Why? Because there is that symmetry between the two. So remember that. Again, put it in your summary book. Really, really important. And believe it or not, that is the end of this video as well. So what have we covered? Isomorphic graphs, making sure that we can draw the same thing in different ways. Yes, connected graphs, no loners, but doesn't have to have all points connected to all other points. And adjacency matrices, just a way of showing the connections on a graph in a different way with a matrix. Thanks very much for watching. Hopefully it's been useful. If it has, let me know, subscribe, let your mates know, let your teachers know that there's actually a pretty good resource out there. And hopefully I'll see you in other videos. My name's Darren, take care, bye-bye.